Hello friends, so while proceeding with this chapter, in this session, the topic which I will be covering is the different types of chemical reactions. First is the combination reaction. So as the name suggests, in a combination reaction, two or more substances combine together to form one substance. The example being when carbon reacts with oxygen, we get carbon dioxide. Similarly, when sulfur reacts with oxygen, we get sulfur dioxide. Combination reactions are generally exothermic in nature. That is when energy is released when two or more substances combine together. So the example in this case can be when calcium oxide is treated in water, we get energy as a byproduct. The next is a decomposition reaction. In case of decomposition reaction, one substance is broken down into two or more simpler substances. So decomposition reaction is also called as the reverse of combination reaction. So in case of decomposition reaction, there are three types of decomposition reactions which takes place by using electricity, heat and light. So when the first one being is the electrolysis. So it is simply the chemical reaction in which electricity is used for the decomposition reaction. So the example here we can take is when electricity is made to pass through water, it splits into hydrogen and oxygen molecule. The next one being the thermal decomposition. Again, the name suggests that when heat energy is used for the reaction, it is called as thermal decomposition. The example being when calcium carbonate is heated, we get calcium oxide and oxygen. The third one being is the photochemical decomposition. Photochemical decomposition means when a chemical reaction is carried out in presence of light. The example we can take is silver bromide. When silver bromide is treated in presence of light, we get silver and bromide molecules. The third type of chemical reaction is the displacement reaction. So in displacement reaction, one reactive element tries and replaces another reactive element which is lower in reactivity as compared to the previous one. So we will take the example of zinc reacting with copper sulfate, which gives us zinc sulfate plus copper. The reactivity can be seen on right hand side. The table shows that potassium is highly reactive, and in the series you can see that the reactivity reduces with each of the element which is listed below. The fourth one being is the double displacement reaction. So in a compound, when two or more atoms or a group of atoms tries to displace another atom or a group of atom, it is called as double displacement reaction. The example here can be taken is when barium chloride is treated with sodium sulfate, you get barium sulfate plus sodium chloride. You can see that the displacement of chlorine and sulfate ion has taken place, and hence it is called as double displacement. The fifth being neutralization reaction. So in a chemical reaction, when an acidic compound reacts with a basic compound to produce salt and water, it is called as neutralization. So when potassium basic gets treated with hydrochloric acid, we get potassium chloride plus water molecule. The sixth one being oxidation reactions. So in a chemical reaction, when a substance gains oxygen or reduces hydrogen, it is called as oxidation reaction. Now, since oxygen is electronegative and hydrogen is electropositive, oxidation can be defined as a chemical reaction in which a substance gains electronegative radical or reduces electropositive radical. The example which we can take here is, again, when gain of oxygen, which is oxidation. On the other hand, gain of an electronegative element, that is when magnesium is treated with chlorine, we get magnesium chloride. The seventh one being is the reduction reaction. Now, in case of reduction reaction, it is defined as a chemical equation in which a substance gains hydrogen or reduces oxygen. Now, again, as I said before, that hydrogen is electropositive and oxygen is electronegative. So reduction can be defined as a chemical reaction in which a substance gains an electropositive radical and reduces an electronegative radical. The example here which we can take is hydrochloric acid getting split into hydrogen plus chlorine. Now, lastly, the eighth reaction is called as redox reaction. So, in a chemical reaction, when oxidation and reduction is taking place simultaneously, it is called as a reduction reaction. Let's take the example of copper and iron. When copper is treated, it gets split into a copper ion. That means there is a loss of 2 electrons. On the other hand, iron molecule gains these 2 electrons and it undergoes reduction, and thus Cu plus I2 gives us CuI2. Okay, let's get back to what we have studied when we were in 9th grade. Although you already have studied it before, but we will just take examples so that we revise what we have studied before. Let's take example of Al2SO4 whole 3 compound. Here we just have to calculate the number of atoms of each element present in this compound. So firstly, the important thing which is to be considered is the subscript and what is present inside the parenthesis. Here the subscript indicates that there are 3 units of SO4 which is present. So when I write for aluminium, I can see that the subscript 2 indicates there are 2 atoms of aluminium element present. On the other hand, for sulfur, there are 3 sulfur atoms which are present. And for oxygen, it is 4 into 3, 12. Let's take another example. The dot indicates that there is a presence of hydrate substance here, and the number 6, which is preceding H2O, indicates the number of water molecule which is present. So when we start off with cobalt, there is just 1 atom of cobalt which is present. For chlorine, there are 2 atoms. For hydrogen, it is 6 into 2, which is 12. And oxygen, it is 6. You have already studied balancing of chemical reaction, but we will just take one example so that we are aware of what we will be doing further. Let's take example when iron is treated with water to produce iron oxide and hydrogen gas is liberated. I am just writing the skeleton equation first. When iron is treated with water, gives iron oxide plus hydrogen. Now this is the LHS of the equation. This is the RHS. We will calculate the number of atoms of each element which is present for iron, for hydrogen, and for oxygen. On the left hand side, iron is 1. On the right hand side, it is 3. Hydrogen, on the other hand, here is 2. Over here, it's 2. Oxygen is 1, and over here, it's 4. Now we have to balance this equation so that the number of atoms of each element is same on right hand side as well as on left hand side. We will start off with iron first. As we can see that there are 3 atoms here, we will add 3 on the left hand side. Now iron is balanced. Now when we see oxygen over here it is present 4 and over here it is present as 1. What we will do is we will add 4 on the left hand side. Now oxygen is balanced, but on balancing oxygen we can see that the hydrogen atoms on the left hand side has increased. Now it is 4 into 2, 8. On the other hand it is 2 on this side. So we will just add 4 over here. And now this is the balanced equation. Going to the next topic, it is the oxidation number. Now oxidation number indicates the degree of oxidation of an atom in a chemical compound. There are various rules which are being followed in order to find the oxidation number of any chemical compound. I will start off, the first one being that the oxidation number of any element in its elementary form is 0. For example, in chlorine, N2O2, the oxidation number in all these will be 0. The second one being the oxidation number in case of a monoatomic ion is equal to the charge which is present on the ion. For example, for calcium, the oxidation number here is +2. For chlorine ion, the oxidation number is -1. The third one being when hydrogen is clubbed with a non-metal, in that case the oxidation number of hydrogen will be positive. On the other hand, when hydrogen is clubbed with a metal, the oxidation number of hydrogen will be negative. The example being, in case of hydrochloric acid, the oxidation number of hydrogen is +1. In case of lithium halide, the oxidation number of hydrogen is -1. Next one being, in case of polyatomic compounds, the oxidation number is equal to the charge which is present on the ion. For example, in SO4, the summation of the oxidation number of each atom is equal to the charge which is present on the ion, which is -2. Now next is when a compound is made up of 2 metals. In that case, the metal which is highly electronegative will have a negative oxidation number and the other metal will have a positive oxidation number. That explains the 5th point. The 6th point being, when a compound is made up of metal and a non-metal, the non-metal will be given a negative oxidation number and the metal will be given a positive oxidation number. 7th one being, oxidation number is equal to that of oxidation state. So in H2O, the oxidation number and oxidation state of oxygen is both -2. Lastly, the oxidation number of oxygen in most of the compounds is -2. However, it varies in certain cases. For example, in peroxides, in H2O2, oxidation number of hydrogen is -1. On the other hand, in fluorides, the oxidation number of oxygen is +1. Now, we will take an example to calculate the oxidation number. Let's start with methane, CH4. Here we want to find out the oxidation number of carbon. Let's keep it X. We know that oxidation number of hydrogen is +1 and in total this compound is electrically neutral, so x plus 1 into 4 will be 0, and thus the value of x is equal to minus 4. Let's take another example where we have to find out the oxidation number of manganese. We are giving this x. For potassium, we know that it's plus 1. For oxygen, it is minus 2. Thus 1 plus x minus 2 into 4, it gives 0. And thus x is equal to plus 7. The next point is the fractional oxidation number. Fractional oxidation number indicates that the oxidation number of an element is in fraction and not as a whole number. Now this concept as a whole is difficult to digest because we know that electrons are neither distributed or neither shared in fractions, but they are always in whole numbers. But this usually happens that the oxidation number of each atom is a whole number in the total electronic configuration. It is just that the average of it comes out to be a fraction. Let's take the example of N3H to explain fractional oxidation number. Here we have to find out the oxidation number of N, so I'm marking it as X. So 3x, as we know, for hydrogen it's plus 1, is equal to 0, and thus x is equal to minus 1 by 3. So here we notice that the oxidation state of nitrogen is a fraction and not a whole number. Last topic here is I would like to say the difference between valency and oxidation. What is the difference between the two? Firstly, valency, as we know, it is the capability of one element to combine with another in order to form a compound. Oxidation, on the other hand, is just a sign, positive or negative, which is assigned to an element based on some arbitrary rules. Now next is valency, doesn't have any positive or negative sign, it is just a number, but oxidation has a positive or negative sign, as we explained in case of calcium, as we explained over here. It is plus 2 in case of calcium ion and minus 1 in case of chlorine ion. Now except for noble gases, the valency of no other element is 0, but in case of oxidation number, the oxidation number can be 0 of an element in a compound. Now next is in case of valency, the valency of all the elements are almost fixed. You can see that there are hardly any variation of any element in any compound. On the other hand, for oxidation number, the oxidation number of one element can change with the change of compound.